this goes like all the way back to 4th grade, like that's where you like first deal with like symmetry. So you can have like a line of symmetry, where like you have a whole line that cuts a graph in half, which in this case, like these are showing like either the x-axis or the y-axis. You also can have, if y'all remember, like in quadratics, we found that line of the axis of symmetry. Don't remember it was negative b over 2a. It gives you the x value of the vertex, which also gives you the x value or the axis of symmetry. So you can have that, but we're not really going to be talking about that. We're going to be talking more like, is it an actual axis, x or y axis line? The other thing we have sometimes is a point of symmetry when we're talking specifically about even and odd functions, which is what we did the day we did those colored pages with your parent functions. On all those we identified like the symmetry. Now once we make transformations, a lot of times that changes and that symmetry goes away. Okay, so the x-axis and y-axis are common lines of symmetry. The origin is typically our common point of symmetry. Yes, that can move, but as far as like for even and odd, it's the axis line or the point of symmetry. All right, so they're giving you like some like graphical information based on algebraic tests that you can use to determine whether or not something's symmetric. Casey, this was that day that we were doing those colored sheets and you're like, how do you know? And I flipped it over to the back and it had to do with negative x and positive x, like f of x is equal to negative f of x or whatever. So that's kind of what we're talking about here. So this also goes back to when y'all had Miss Rose in 8th grade. Y'all remember when y'all did like, did y'all have her in 8th grade? Yes. And y'all had to do like reflections and rotations and all that stuff. Do y'all remember that? Like, which is kind of difficult, I think, in 8th grade. Like, it's kind of weird. But anyway, what happens with those, I don't know if y'all remember that, was if you have an x-axis, sorry, I'm losing my train of thought. Sorry, let me show you. This would become x negative y. If you have, like if you look graphically, if your x-axis is your symmetry, then your x and your y values change signs. If you think about that, like if like this is your x-axis, then whatever is up here is now down here, so the y value changes signs. Does that make sense? But the x value stays the same. Is that logical? Yes? Okay. If it, so algebraically, like to do that, you take your y value and it becomes negative y. The x value stays the same. So we can swap them out. All right, for the y-axis, what happens is negative x, you have negative y, meaning like if I look at it here, if I bring an axis line up here and I'm looking at it's reflecting across this axis, or this is my symmetry, then here's a good graph as a representation of that. Like this point and this point have the same y value, one's positive, one's negative. Is that, the same x value, but the y value stays the same, and the x is positive over here, negative over here, but it's the same distance from your axis line. Does that make sense? Again, I apologize guys, like my head hurts really bad. All right, so by doing that, we basically swap out positive x for negative x. All right, if it is at the origin, they both change. X becomes negative x, y becomes negative y, so that's exactly what we're gonna write here. Y becomes negative y, and x becomes negative x. Visually, the really easy way to see that, and this one up here I'll be able to show that to you, is right here. So if my origin is my point of symmetry, then if you notice like this is going up over here and down over here, if I rotate my graph around 180 degrees, up over here, down over here, it looks exactly the same when we rotate it 180 degrees. Does that make sense? Yes, if my origin is my point of symmetry. Okay, so that's just kind of the way to tell. This one is the x-axis is, this one the y-axis is, this one the point is. So that's kind of an example of each one. Okay, so down here, usually you can tell visually, but sometimes it can be more than one. So that's one thing you also have to think about too. So if we look at this here, if I look at my x-axis, because we're checking each one, clearly the top and the bottom don't look the same, so it's not the x-axis. Does that make sense? Here, the y-axis, if I look at the left side and the right side, they are exactly the same, so y-axis is for sure that. My origin, if I rotate that around, it's not going to be the same. Good way to tell about the origin too is this quadrant and this quadrant would look the same, and or this quadrant and this quadrant would look the same. Is that logical to y'all? Well, they would be opposites of each other. So clearly that's not it, so the only one there is the y-axis. Okay, so to prove that mathematically, remember for the y-axis it says that I replace my x with a negative x. So when I plug that in, I have y is equal to negative x to the fourth minus 4 times negative x squared. So when I evaluate that out, negative x to the fourth still gives me x to the fourth. When I evaluate this out, I have minus 4. This still stays, this becomes a positive x squared. So if you notice, this and this is the same as the original. And if they are the same as the if it's the same as the original, then it's a y-axis. Is that, are y'all okay there? All right. Or that axis is true in this case because it was a y-axis we were checking. All right, so this one here, does it appear that it's the same on the top and the bottom? Exactly the same. Like above, below? No. Does it appear left and right? No. So then your other test is basically your alternate quadrants or your rotation test, and that one does in fact look the same, right? So we're saying it looks like it is the origin. So mathematically, to check the origin, I've got to check both, I've got to change the sign of both x and y. Are we okay there? So if I take negative x and I multiply it times negative y, I get positive, and I write it 6 over there. Negative x times positive y, negative y gives me a positive x, y is equal to 6. If it is the same as the original. So if it's the same as the original, then it is what I thought it was. If it doesn't come out as the same as the original mathematically, then I was wrong about what I thought. Does that make sense? Everybody okay there? Okay, so back here, all right, as I look at this one, does it look like x? Top and bottom the same? Looks that way. Does it look like y? No. Does it look like origin? No. So the only one I need to check is my x, which means if you go back over here and you look, for your x-axis, you're looking at a change for y. Does that make sense? Okay, so that means where my y is, I need to put in the negative. So I have 4 times x plus 3 squared plus negative y squared is equal to 16. I'm not going to square all this out because I want it to look this way. Does that make sense? So I'm not changing that. Negative y squared is going to become y positive y squared. So that works. It's the same. So it was true for what I thought it was.
Wait, I have a question.
Yes, dear.
Why is negative y squared plus is y squared? Why isn't it just y?
Negative y times negative y is positive y squared. Anything times itself, like x times x
I
is
think
x squared.
I think he's asking why do you keep the squared, because negative and negative, it's already squared.
Yeah, that's what we
Because
said.
when you
No.
multiply negative y.
Y times y is y squared. Negative times negative becomes positive. You gotta square everything inside the parentheses. So I'm squaring the negative, which becomes positive, and I'm squaring y, which becomes y squared.
Mm,
Did we forget that y times y is y squared?
No, I think that he was asking if you square it, so like if you were to write it twice, why would you keep the square if you're squaring it?
I didn't write it twice.
No, I know, but
I mean, if I wrote it twice, I would have to write this, which I don't know why I would write that. I mean, I could, but
Alright.
is that, I mean, is there still a question?
No, there's no
Or am I
question.
just
If
not
like-
understanding the
No,
If
question?
like
there's no
three was
question.
in, if it was like negative 3 squared, it wouldn't be.
It would be x plus 3 times x plus 3, which then I would
Yeah.
have to FOIL all that out and then multiply it times 4, which I don't need to do because I need it to be in the same format. Is that what you're talking about?
No, I'm good
he's
now.
just saying
Yes,
if you square
yes.
it, why are you keeping it squared? Is what he was
Because it has to-
asking, but it makes
Yeah,
sense. You're
but
good.
it has, cause it has to stay in the same format.
Okay, so are we okay?
Yeah, we're good.
Okay, cause I still am not following, but again, I have a really bad headache, so there's that. Okay, so, alright, next one. Alright, so does it look like x-axis, top and bottom?
Yes.
Okay, does it look like y-axis, left and right?
Yes.
Does it look like the origin?
Yes.
Meaning the diagonals, yes. Okay, so I really don't have to check 3 things, but I do have to check 2. Does that make sense?
No.
I mean, really, in all actuality, you should check each one separately to prove each one. Like, I'm gonna do it that way, just to make sure, like, y'all understand that. So I'm gonna do, since it's x-axis, which is top and bottom, then I'm gonna check the y first. Does that make sense?
Mm-hmm.
Alright, so I would have negative y squared minus x squared is supposed to equal 1. This would become y squared minus x squared is still equal to 1. That one's okay. If I check x squared, that means I've got to change, if I check in y squared, then I'm gonna plug my negative in here. So y squared minus negative x squared equals 1. So y squared minus, this becomes positive x squared equals 1. That's the same. And if I plug them both in, then I'd have negative y squared minus negative x squared equal to 1. This becomes positive, this becomes positive, equals 1, they're the same. So, all 3 worked, I proved it mathematically.
I thought you said you only had to check 2.
Do what?
You said you could only.
Technically you could get by with checking y first, or checking x first, or you could get by with checking them both, as long as you don't make any sign mistakes and you're okay. Everybody okay there? Typically, if it's x and y, it's usually also gonna be the origin. But, I couldn't tell you that's 100% true all the time, because my brain doesn't work that good today. Okay, so, this one right here, does it look like x-axis?
No.
Does it look like y-axis?
No.
Does it look like the origin?
No.
Good, cause it's not any of those.
No. Heck yeah.
So, that one is none.
That was awesome.
I could prove it by, honestly, probably the best way to prove it would be doing this, changing both of them, because really, if you change both, it should prove that good enough. But, since I'm saying no, I'm not needing to prove myself. Alright, so what about this one? X-axis,
No.
Y-axis,
Yes.
origin.
No.
Okay, so if all I have to do is y-axis, then I'm plugging in my negative x. So y equals negative on the outside, absolute value negative x, minus 2. This negative stays. Absolute value of negative x is positive x, and minus 2 stays. You all okay there?
Mm-hmm.
And if you pulled this out, this would have been negative x minus 2, in which case they would be the same. You all okay there? All good?
All good.
Okay. Alright, so even and odd. A function is even if it has, it says if it's symmetric with respect to, I'm gonna say if it's symmetric at the y-axis. Alright? That would mean cases we were talking about the other day, f of negative x is equal to f of positive x. So this is typically even powered functions. Absolute value also, assuming there aren't transformations, okay? So, absolute value falls under that because absolute value is basically like, almost exactly like a quadratic, like it operates exactly the way a quadratic does. If a function is odd, meaning odd powers, it's usually symmetric at the origin. Again, not having to do with if we don't have transformations. So in this case, f of negative x is equal to negative f of x, meaning their signs are the opposite. So evens, if I plug in negative x, it's gonna look like the original function. Odds, if I plug in a negative x, the signs are gonna swap. Does that make sense? And to be odd, it has to swap for everything in the function. So you'll kind of see what we're talking about here. Let me kind of explain something here too as we get to this, in case you don't remember. Constants, that would mean numbers at the back of your function, have an understood power of 1. Okay? So if I just have 5, that means 5 to the first power because that's how I get 5. Does that make sense? Yes? Alright, so keep that in mind as we go because I'm going to teach you a trick here in just a second. Alright, so here, this is, I'm pretty sure this is an odd function. I need to prove that. Okay? So if I do f of negative x is equal to, so I'm going to replace this x with a negative x. I'm going to put my 3 on the outside, minus a negative x here. Okay, so this becomes negative x cubed because negative, negative, negative is still negative. This becomes positive x, right? Both signs changed. If everything changes, then it is an odd function and it is symmetric at the origin. That's what that means right up here where it says f of negative x is equal to negative f of x, meaning every single piece of the function changes signs when I plug negative x in place of x. Y'all have got to use parentheses here, you'll mess this up. Everybody okay there? Alright, this one, I have an even power here, right? Yes? So initially I would think, okay, it's an even function. However, this guy right here has a power of what? 1, which is not even, right? Are we in agreement there? Okay. So if I look at this, so we just have to you really just sometimes just have to check and see. So f of negative x is equal to negative x times negative x squared plus 6, right? There was no x to plug into there, so I don't have to worry about it. Oops, sorry, I put a whole extra x there, sorry. It was supposed to be a negative sign, sorry. Negative out front, not negative x, just a negative out front, sorry y'all. Alright, so this right here, this stays, right? this becomes positive x squared, and this is plus 6. So if we look, this one right here and this one up here are the same exact function. My 6 didn't change because there wasn't an x attached to it, so I didn't have to worry about the sign, right? So if my original function and my new one are exactly the same, then it's even, which means I'm at the y-axis for my symmetry. We okay there?
Wait. I'm getting it mixed up.
For it to be odd, every single piece of the equation must change signs.
No, I get that, but how are you finding where it's symmetry at? I know that we just did that,
Because
but-
odd functions, it says it right up here, odd functions are at the origin and even functions are at the y-axis.
So we're never doing x-axis?
We don't,
This
yeah, we don't
one?
really have to worry about those. Usually visually we'll talk about that now.
Okay.
But typically, they don't ask you about the x, it's usually even or odd. And and even and odd has to do with the y-axis and the, origin. Does that make sense? Usually, if it's the x-axis, it's not a function anyway, cause it's those conic equations that have a y squared, and we're not really gonna deal with those too terribly much. So, if you're having to deal with like, an x-axis, it's gonna be visual. You're just gonna have to prove it with plugging in. Does that make sense? These though, like when they give you the equation, it's either gonna be the origin, the y-axis, or neither of those. So if we look at this one, I have f of negative x is equal to negative x cubed minus negative x squared minus 2 times negative x. Alright, so here, this is cubed. Well, a negative to an odd power is gonna be negative, right? This is gonna be negative x, it's gonna be squared, it's an even power, meaning it's gonna be positive x squared. But I had a subtraction in front of it, so I gotta bring it down. Here, this is a negative x, but I have times a negative 2, which is gonna give me plus 2x. So if we look at this one in comparison to the original, this one changed signs, this one stayed the same, this one changed signs, which means I have a mixture, right? Yes?
Right.
Alright, so if I have a mixture, it's neither. We okay there? Alright, so let's take a look at this one. I have f of negative x is equal to, now, this is a square root function, right? Okay, a square root function, I'm taking the square root of a square, right? So my square is what? What kind? Even, odd?
Even.
Even. So when I square the negative, what's gonna happen? It's gonna go right back to being positive, right? My minus 4 isn't gonna change. So we think it's gonna end up being what type? An even function. So, and I'm gonna prove it. So I've got negative x squared minus 4, which becomes square root of x squared minus 4, which is exactly what I had. So it is even, which is what we thought, at the y-axis. Okay, so I'm gonna teach you a trick. Alright, ready? We'll slide over here in your margin. You can have that, Joey? I wanna make sure you had it before I moved it over.
Yeah, I'm good.
Got it?
Yes, ma'am.
Okay, so here's the deal. If all switch signs, and you should be able to tell because you should know what's gonna happen if you take a negative to an even or to an odd power. If all switch signs, then it's gonna be odd. If all stay, then even. If it's mixed, So we should be able to kind of do this without really even doing any work. So I have an x to an odd power, because that's to the power of 1, right? So that x, is it going to stay or is it going to change? It's going to change, right? Are we okay there? Yes? Alright, so what happens when things change? It's going to be odd, right? Like we've already decided, we already know that's what it should be, right? So if I go in and I plug it in, I can prove it. Negative 8 over negative x is going to give me positive 8 over x. Everything in the problem changed, right?
Wait.
I didn't see no.
The 8 became positive, did it not?
Yeah, but it's a positive x.
Okay, yeah, but I mean, look at it as a fraction. Read it as a fraction.
Then you would pull
It was a negative fraction, right? Now it's a positive fraction. Yes? Would we agree? It's a positive fraction?
So you would have to pull the negative out front.
So the whole thing changed. Yeah, does that make sense? Like as a whole it changed because it's multiplied together. Does that make sense? So because as a whole it changed, that means it's odd. So then we're at the origin. Odd is origin.
I got a question.
O and O, yes.
How is that a shortcut?
Because I already knew in advance. Like, I didn't even need to look at it. Okay, look at this. Well, let me finish this, and then I'll show you on the board. Alright, so let's take a look at this one. My x is to what power here?
1.
My x is the first power, which means it's
Odd.
odd. Now, this is a tricky function because it's absolute value, so it's a little bit difficult here. But
It's gonna be even.
if I look at that, if I plug in a negative x, is it going to matter? No, it's going to stay the same because of the absolute value. It'd be the same thing if it was x squared, right?
Uh-huh.
So it's still going to say x. So are either of these things changing?
Nope.
No, so
Even. It stayed the same.
it's going to stay the same. Now, here's the issue with this one.
Oh Lord.
Sorry, this right here,
Ugh.
that shifts your graph to the left.
Mm-hmm.
This is.
Wait, what?
Think about a quadratic. So you remember when we had quadratics and you had it in vertex form, and what was in the parentheses was your left and right movement? Okay, transformation's the same with an if this was just an x, we wouldn't have to worry about it. And if it was a 1 on the outside, we wouldn't have to worry about it. But because the x is because the 1 is on the inside, this shifts your whole graph to the left. Like, it's gonna make my graph look like this. Which means it's already moved from, it's not at the origin or at the axis line already. Because the original graph is shifted over. Does that make sense? Yes?
Mm-hmm.
Okay. Now, so if I plug in negative, I mean really in all actuality, the whole thing is gonna stay the same. So it would still be qualified as an even function. However, it does not have symmetry at that axis line. Does that make sense? Because the original is shifted over here. So the symmetry stays the same, it's just the symmetry is right here. Does that make sense? That one's just a little bit different.
So
Yes, no. Grab it in your calculator and look at it. Like, grab it in your calculator. You all know how to graph absolute value? You have to go to math, I think.
Yes, ma'am.
So go to alpha y equals and then go to math.
Lord, if I knew that you could do this in the calculator, I would have been.
Let me see if it's in there.
It's been a lot easier. It's in math. You gotta go to num. It's right here. It's in num. Num.
It made it worse.
No, there it is.
Look at that. Yeah.
Why can't I get to it?
Well, there's being a blue.
Go over to number,
Yeah.
I see x plus 1.
So,
then graph
you
it.
just don't, so,
Okay.
I mean,
So-
do you not put,
Okay, so normally like it says like, and here it doesn't necessarily have to say like, I actually went a step further
Is
on
it
your
either?
instructions. because it says even, odd, or neither, it doesn't say which axis or where it is. We were writing where it was, and we really don't have to, like we shouldn't have.
It says if describe the symmetry.
Yeah, it says describe the symmetry. So here the axis of symmetry is actually at -1, right? Does that make sense? Yes? Okay. So now go back to y2 and do the same thing, except put a negative x in there and see what happens. Because a lot of times, like graphing, it's a good way to tell. Because we take the absolute value. Did you still put +1?
It just went to the
right. Yeah, it went to a positive one.
Yeah. So so our axis of symmetry changes here.
It's the y-axis.
So no, it's not the y-axis.
It's X.
But okay, so here's the deal. So because this function is weird, it does not really qualify as either one. Does that make sense? So a lot of times, like, the graph is a little easier way to tell by looking, because of that -1, because that one inside there is going to shift things. You remember how in an absolute value, like, we set it equal to something on the outside, and we have two different signs over there? That's what caused absolute values to be kind of weird. If it was just the x, we wouldn't have to worry about it, but it's not just the x. Does that make sense?
When I see absolute